As many of these detailing projects do, the modifications to this radiator started off simple and just kind of grew from there. When the tooling for this kit was produced way back in the early 70s, Ertl did a nice job on the radiator. It's almost a kit in its own right, being composed of 5 separate parts as shown here, with the exception of this one in the top right corner, which is the transmission top cover. The radiator's front panel is molded with an air conditioning condenser, and for this model, I wanted to delete this to simulate a truck built without air conditioning from the factory. Although I can't say for sure that the truck I'm modeling was built without air conditioning, that spec was not unusual in the 70s and 80s, especially up here in Canada, on trucks operated by construction fleets like this one. Another example of useful parts from the Snap Kit, Kenworth Aerodyne or Pete 359 kits in 1/25th scale is this radiator half, which provides a good sized piece of radiator fin textured material. The white rectangular portion in the center was what we'll be using, and everything marked in red and to the outside will be trimmed away. Saw cut edges are sanded smooth, and the finished piece of radiator texture material is glued in place on the radiator frame, keeping it centered top to bottom and side to side. Open areas around the edges are filled in with styrene strip. I use 40 thou thick by 156 wide for the vertical pieces, and the horizontal sections are 40 thou thick by 60 thou wide. Final trimming is done to match the basic contours of the radiator. Although the smooth border around the cooling fin texture is slightly wider than it would be on a real radiator, assembled and painted on the finished model, the appearance will be acceptable. One thing I did not care for was the open bottom of the top radiator tank. Only part of this open space is closed in when the tank is installed on top of the radiator, with the remaining hollow portion still quite visible. This is easy to correct by gluing a small piece of 10 thou styrene sheet to the bottom of the tank, sanding the edges smooth, and restoring the locator pin holes. Being 10 thousandths of an inch taller doesn't affect the fit of the finished tank, but the closed-in bottom on the top tank, as opposed to being a hollow part, greatly improves the appearance of the finished radiator. On pictures of Transtar 4300 radiators I was able to locate, this series of ribs is quite visible. While the model radiator is smooth, with no texture of any kind. There is a recessed area approximately 30 thousandths of an inch in depth, which makes 30 thou square styrene strip an ideal material to replicate these ribs. To cut multiple identical parts, a simple jig was made by gluing 40 thou thick styrene strip at a 45-degree angle on a piece of scrap styrene sheet, spacing them 30 thou apart to fit the 30 thou square strip in between. 2 vertical cuts were made with a fine-tooth razor saw, spaced the same distance apart as the recessed area on the side of the radiator. In use, a piece of 30 thou styrene strip is placed in the jig, and a single-edge razor blade is used to make the first plunge cut, then move to the other slot for a second cut, resulting in a series of identical pieces with 45-degree ends that are glued onto the side of the radiator as shown here, and although these don't replicate the prototype ribs 100%, the added texture improves the appearance of the finished model. Because I'm replacing the kit-supplied V800 engine with a Cummins, only one radiator hose going to the upper tank will be necessary. On the real trucks, unused ports are covered with blanking plates like the one visible here, which is modeled with a styrene disc filed to an oval shape and a pair of bolt head castings. 2 pieces of 20 thou by 1/8 wide styrene strip are also glued to the upper radiator tank to represent the attachment points for the hood stop cables. The kit supplied air intake component, which attaches to the side of the radiator, matches the prototype truck's location, but looks a little undersized when compared to the one in the picture. The real one also isn't chrome plated. With chrome removed, the kit supplied part is cleaned up. A piece of 40 thou styrene sheet is drilled to match the round projection, which is where the intake pipe attaches, and is glued on to complete the box and bulk out the kit part to a more realistic thickness. Styrene strips are then added to fill in any hollow spots and close off the ends, and the finished assembly is sanded smooth. Radiator braces are another detail typically not provided in model truck kits, and these are easily replicated using wire, styrene angle, discs, and some bolt head castings. I used 100 thou styrene angle, cut just over 1/8 of an inch long, with 032 brass wire being used for the actual brace. Styrene discs and bolt head castings made up the fasteners on the ends. After a couple of false starts and failed attempts, I can say from experience that it's actually easier to pre-drill all the individual components on the bench as shown here, assemble onto the brass rod, and glue together, rather than try to assemble the complete stack and then drill through 5 layers, keeping the drill centered. The brass rod is cut to project just slightly beyond the bolt head casting at either end, and this simulates a threaded portion provided for adjustment on the real truck. At this point, neither the radiator or the braces are glued in place. We want these parts to remain removable so they can be painted separately and not installed permanently until the engine is in place. This demonstration run shows installation of radiator and engine for test fitting purposes, and also how the radiator will go onto the model when it's all finished at final assembly. Brass rods go into the frame brackets first. The engine sits down on its mounts. And the radiator slides into the kit-provided slots on the frame. Brass rod is now slid up into the radiator brackets. And if this were final assembly, they'd be glued into place and the paint touched up with a fine brush. As a last touch, the radiator cap gets installed. A radiator cap is molded into the upper tank, but the relief is very shallow, and I decided to drill out this area and add a piece of 3/32 aluminum tube to receive a built-up radiator cap. This was made by punching a styrene disc approximately 100 thou diameter out of 20 thou sheet. This was placed on a smooth metal surface, which in this case is the backside of an X-Acto hobby square. 2 short pieces of 40 thou styrene rod were glued on to simulate the projecting ears on the side of a radiator cap. These are attached with Tamiya liquid cement, and this will cause the disc to stick to the square, but this actually works to your advantage because it helps hold the piece in place for filing and finish sanding, and it can be easily popped off afterwards with a razor blade or a hobby knife. Glue the cap to a short piece of 1/16 styrene rod, and it's shown here with a pair of pennies for size comparison. Finished radiator cap in place, with one final detail in the form of a styrene rivet glued in place dead center. This separate rad cap can be painted off the model, ensuring a clean color separation when it's installed at final assembly. And that brings us to the end of this installment, with the air conditioning delete modified rad set in place. Looking more like a truck at this stage, but lots of fun little modeling projects still to do.